Hong Kong to Rotterdam, Singapore to New York, the past 20 years have seen a massive increase in world trade, and with it, the volume of world shipping. To frequently amended schedules and orders has been added ever more time at anchor, waiting for berths to become free, demanding ever more care from masters, crews and pilots concerned for the safety of their vessels. For the past 20 years have seen over 1,000 anchor-related incidents, mainly among the largest vessels. Anchors have been let go in the wrong place, at the wrong time, in the wrong way. Whole cables have been lost and windlasses shattered. The cost in expenditure, careers and equipment is immense and poses the awkward question: do those responsible properly understand the basic design principles and limitations of their anchoring equipment? In addressing this question head-on, and since most reported incidents have been aboard large vessels, our program looks closely at two separate anchorings aboard the same bulk carrier plying between Europe and North America. In illustrating here what's best in anchoring practice, we shall also point out the pitfalls for ships of all sizes. Our first destination and anchorage is in Sept-Îles on Canada's St. Lawrence River. Our second, different master, different crew, same ship, will be Rotterdam in Holland. To anchor in either location, a master will aim to bring his ship over the precise position he has chosen within the area assigned him by the port authorities, making it crucial that he find out in advance everything he can about his anchoring ground. For the busy Maas approach to Rotterdam, the chart shows the extent of the anchorage, available depth, and the nature of the seabed. The master will also need to know the latest local weather forecast and the prevailing tides and currents, as well as any subsea pipelines, cables, wrecks, reefs or shoals in the vicinity, and where precisely they are located. The bridge team must now plan how to take the way off their ship while plotting a course through others already at anchor. Finally, the master must work out how many shackles he will need to bring his ship up safely and in the correct position. All of which must now be carefully communicated to both bridge and deck crews.
Well, before engaging the gear, we'll inform the bridge, and then we can start lowering. Okay?
We will start slowing down at the entrance, at the harbour limits of Sept-Îles. We hope to have reduced to about 4 or 5 knots by the time we approach pilot station. The tide is expected to be ebbing at that time, and also we will see the general direction of the wind and in which direction the other ships at Anchorage are laying. We hope to work ourselves into the same heading as the other vessels. Once we are in our chosen position, we will get the forward anchor party to start lowering the anchor on power. The depths are about 25 to 28 meters, so we will lower the anchor under power to approximately 1 shackle on deck, which is about 28 meters. Then we will change the anchor onto the brake, take out the gearing, and we will lower the final part of the anchor on the brake because I would not like to keep additional pressure on the gearing. We will still come to a stop and come to a minimum speed so that we can gradually, slowly lay out the cable on the bottom.
It is vital for a ship's master and crew to have a thorough understanding of their anchoring equipment, starting with the anchor itself. Being of cast metal, this is brittle and quite able to shatter on rock, making the safest seabed a soft one, into which an anchor's flukes can bite firmly and remain embedded until weighed. The AC-14 is the most widely used anchor on large ships and VLCCs today, holding up to 15 times its own weight. To the anchor's strength is added the effect of the weight of however many shackles of cable are used. Combined, the two provide the system's total mooring power. Most ships will let go one anchor only, from which the lashings must be cleared away, the stoppers checked, and the spurling pipes cleared on approaching the anchorage. Good seamanship, though, dictates that the second anchor also be cleared against emergency, but leaving the stopper on. Controlling both anchor and cable, the Windlass may appear robust with its hydraulic, electric or steam motor, its drive shaft, clutch, brake, gearing system, the gypsy that guides and controls the cable, and finally both stopper and anchor lashings. The fact is, though, that it's a relatively delicate piece of equipment. Under classification rules, the Windlass is designed to control and stop the anchor chain only, in motion up and down. It is certainly not designed to support the mass of a 200,000-ton ship. Indeed, even the walking out of cable, out of the vertical, will impose an excess load, if not immediately slacked back. Yet excess loads continue to be imposed, and to lead, over time, to metal fatigue and to metal shavings entering the hydraulics, where they can cause serious and mostly unseen damage. Until too late. Of course, on the vast majority of ships, the Windlass is routinely maintained between anchorings, often at the same time as weighing anchor. Greasing through the nipples and on all external moving parts both lubricates and prevents rusting. Filters must also be routinely checked and cleaned, and, vitally, brake linings and screws checked for wear. So far, all the master's plans have been drawn up at sea. At Sept-Îles, the sight of how other ships lie at anchor may lead to modifications.
Position. As soon as I have dropped my way off, I will tell you to start lowering.
So that's a copy that we'll just try it.
Okay, so now we've finished priming the pump, and the pump is running now.
And at every anchorage without exception, repeated checks must be made on the Windlass and other anchoring gear.
We'll check these claw couplings.
Foundations must be inspected and hydraulic pumps tested. The clutch must be engaged and secured.
As soon as I have dropped my way off, I will tell you to start lowering.
Checks, too, must be made on communications between forecastle and bridge, especially on the largest ships, where the sheer distance between the two might otherwise be a problem.
325.
As the ship approaches her anchorage, her master will have been for some time slowly reducing her speed from cruising to approximately 5 knots.
Okay, we have about 1.5 miles to go, and we're already coming down on our speed.